So we're going to go through some of the key terminology. Some of this should be review, which is fine. It's going to be really critical to have just a strong understanding of these terms as we go through the class. Variable, anything that you are interested in studying. So anything you want to study. So it could be something measured directly, right here, like height, weight, number of leg lifts if you're studying exercise, something like that. Those would be called those are called observed variables. OBSERVED, observed variables. You can measure it directly. So if you're interested in, maybe you're a health psychologist and you want to know different factors that contribute to different wellness outcomes, then you might be looking at some physical outcomes like height. So that would be an observed variable. Some things are measured indirectly. So we call these latent variables, LATENT, latent variables. Be something like happiness, aggression, intelligence. So this guy here is looking aggressive or determined, perhaps. And if you wanted to measure determination, you wouldn't be able to use a ruler. He's 8, determined. You would have to have some sort of instrument, some way, some sort of indicators you would look at to make inferences about his level of aggression or determination, like that. So we have variables can be measured directly, and those can be measured indirectly. These are observed variables. These are latent variables. In this class, we're going to treat all the variables like observed variables, but later on in 250, I'm sorry, 350, 385, there we go. In 385, we'll actually take a look at some latent variables, and you'll see how you can work with those as well. Okay, so let's look at some examples here. So Dr. Janice believes that playing rock music will help your baby sleep longer during the night. So in this study, there are two variables, music and sleep. So rock music is your independent variable. We'll talk about that in a second. And then sleep is your dependent variable. So two variables, music and sleep. Okay. So the next terms we need to be very, very comfortable with are independent and dependent variable. We'll use these a lot all throughout the class, all of these classes. You really need to have these straight. One way that people will try to remember it is they'll say that the dependent variable depends on the independent variable. So in this case, the independent variable is Happy Meals, and the dependent variable is children's happiness. So Happy Meals cause children to be happy, or we could say that happiness depends on Happy Meals. So dependent variable, independent variable. The dependent variable depends on the independent variable. Okay. Let's take a look at this one. What are the independent and dependent variables? Well, if we were in class together in a nutritional setting, I would pause and then you would answer. In this case, it's a video, so it would feel a lot like Blue's Clues, which could be awkward for both of us. So perhaps it is intuitive to you that the independent variable is maybe education, reading, literacy, cognitive stimulation, something like that. The dependent variable looks like grades or learning, some kind of achievement outcome. So maybe cognitive stimulation causes or increases some sort of academic outcome, or the academic outcome depends on some level of cognitive stimulation. Okay, what about this one? I like that picture. So independent and dependent variable. Let you think about that for a second. Okay, what did you think about it? That's good. Okay, so the independent variable is Red Bull, and the dependent variable may be hyperness. So energy drinks cause hyperness or hyperactivity in children, depends on maybe caloric intake or caffeine or some sort of nutritional variable. So this would be, again, from the field of, say, health psychology. If depression is the dependent variable, what might the independent variable be? Okay, so depression is the dependent variable. So something causes depression. So there's a lot of things you might fill in over there as possible causes of depression. It could be some relationship issues. It could be some neurochemical issues. It could be maybe some life event. It could be stress. It could be a variety of things. Maybe some genetic cause. So that would be your independent variable, and then your outcome variable would be depression. You could also flip this around. So you could have a variable that could be independent or dependent, or you could even have a chain. It could be something causes this and that causes something else. So if depression is the independent variable, what might be the dependent variable? It could be behavioral outcomes. Could be Maybe trouble in a marriage. So depression might cause a marital strain or some sort of relational strain. Okay, let's say that Dr. Forrester believes that pollutants in the water supply are causing disease. So what are the independent variables? Well, independent variables causing some sort of outcome, causing the dependent variable. So in this case, if the pollutants in the water are causing disease, and the pollutants would be the independent variable, disease will be the dependent variable, sometimes also called the outcome variable, and the independent variable is sometimes called the predictor variable. Those terms are maybe a little more intuitive. So the predictor and the outcome are the independent and the dependent variable. So in the behavioral sciences, we can say there's basically two kinds of research. We have correlational research and we have experimental research. And the main difference here is this level of control that the researcher has in the study. In a correlational study, we're simply studying the relationship between variables. We're measuring, we're observing, we're analyzing, we're drawing conclusions. That's all. In an experimental research, we're manipulating one of the variables of interest. And this is a very important distinction. In a correlational study, we don't do anything other than measure. Now, you might make a very compelling case, say, well, when you measure something, you actually are impacting it in some way, and that's something to be considered. But from a theoretical standpoint, we're over in experiments where we're actually manipulating something. So if we're interested in, click back a couple of, Red Bull and hyperactivity, something like that. In an experiment, we'd be manipulating the amount of Red Bull. So we could give Red Bull to some children and then look at their behavior. In a correlational study, we would not be manipulating that. We would simply look to see, okay, this kid drinks a little Red Bull, he's not that hyperactive. This other kid happens to drink a lot of Red Bull, this kid is hyperactive, but we didn't actually change that ourselves. A correlational study might look something like this. What is the relationship between educational spending and educational achievement? So here we have a scatter plot, and these are two continuous variables. We have the spending per pupil from $0 a year, $2,000 a year, $16,000 a year, and then we have the different countries, and then they're some sort of standardized international test score. So look to see as a relationship between spending and between the achievement, the test score achievement. In this case, is a negative relationship. So that's a correlational study. We didn't manipulate anything. We didn't randomly assign different countries to spend different amounts of money on their children's education to see what the outcome is. Just correlational. Independent variable would be the spending, and on a graph, this is our x-axis on the bottom, and this is our y-axis. It goes up and down. And typically the convention is that the independent variable goes on the x, and the dependent variable goes on the y. So in this case, spending is understood to be the independent variable, and then test scores is understood to be the dependent variable. Now, because it's a correlational study, that's really theoretical. We're assuming that that's the relationship, that this is causing this. We don't really know that for sure. That's the limitation of correlational research, is we can't definitively say that that's what's going on. Maybe it's the opposite. Maybe there's some people that believe in merit pay, or schools should get more finances, more resources if they're succeeding. In that case, their test scores would be causing an increase in economic resources. So this is how it's theoretically set up, but in correlation, we don't really know that for sure in most cases. Now we're talking about experimental research. So I said a bit ago that there's basically correlational research in the behavioral sciences and then experimental research. The big difference being that in experimental research, you're manipulating the independent variable. You are doing something as the researcher and you're looking for causation. There's different types of experiments, and some allow us to make much stronger causal inferences than others. But essentially, that's what we're trying to do. We're trying to make a case that X causes Y. So an example of an experimental research question would be, does Purina One dog food increase your puppy's energy? This is an appropriate question for an experimental design because you can easily manipulate the type of dog food. There's a couple things to consider when you're determining whether or not you can feasibly conduct an experiment in terms of manipulating that variable. You have practical concerns, you have cost concerns, And then there's also ethical concerns. So you could have a situation where, yeah, you really could manipulate this variable, but it would be unethical or harmful to the participant, and so you wouldn't be allowed to do that or wouldn't really want to do that. In the case of dog food, as long as you're deciding between a couple different types of legitimate dog food, there's no problem. So Purina One dog food and Chappie, see, it's easily digestible. We have no reason to think there's anything wrong with this dog food. So if you give some dogs this food and some dogs this food, it's no problem. So in a research design, experimental design, you would manipulate that. You'd give some dogs this dog food, some dogs that food, and you're looking for a difference in the energy. So in this case, sort of implied that this one's creating more energy, and this one, this dog doesn't have as much energy. I just sort of made up this connection. I don't know if this dog food is actually better, but that's it would be appropriate for an experiment. If you wanted to know if giving dogs food created energy and the alternative was not feeding them, well, now we have an ethical issue because you'd have to starve dogs, and there'd be animal rights activists who would be dissatisfied with that sort of experimental design. So you would compare the activity of the different groups. So you'd have your treatment group and your control group. So you'd have you could graph this and say, well, the level of energy is up here for these dogs, and then down here for these dogs, and we draw some conclusions based on that. Independent and dependent variables. So reviewing here, your independent variable is what causes the outcome. So we believe that the type of dog food will cause the outcome. So the independent variable would be type of dog food. I'm going to emphasize type of dog food versus dog food. A lot of people would say, oh, the independent variable is dog food. But again, that sort of suggests that the alternative is maybe people food or no food. Well, of course, having food, increases your energy level versus not eating, as we previously established. But the type of dog food. In this case, sometimes we'll talk about levels of an independent variable. So in this case, the independent variable is type of dog food, and there's two levels, Purina 1 and Chappie. So let's take a look at some of these other examples and determine, would this be better for a correlational study or better for an experiment? The first one, does the murder rate in a community affect its children's self-esteem? So if you want to pause the video and then think about it and then say if I said the same thing you said, you can, or just listen. Whatever works for you, you're an independent learner. Does the murder rate in a community affect its children's self-esteem? Well, independent variable would be murder rate, and dependent variable would be the self-esteem of the children in that community. Well, this would have to be conducted as a correlational study, because in an experiment you would have to manipulate the murder rate. So you would get a random sample of communities, maybe in the U.S. You'd randomly pick cities or communities, and you have to randomly assign them to different murder rates. You have to go to each community and murder a certain number of people, and then measure the self-esteem of the children in that community. So it'd be an example of where it would be not feasible to do that. It would be too expensive and it would be unethical to murder people. Will changing toothpaste brighten my smile? Okay. Well, that would be an experiment because there's no reason not to do that. You could just buy a different toothpaste and then see if your smile is brighter. No problem. You could just buy it and it doesn't cost too much and it's not really unethical. Do more dentists really choose Crest? Okay. Also correlational. We're just looking to see, really this is actually just descriptive statistics. We just want to know the percentage of dentists who choose Crest. So very basic research question. Does smoking increase the risk of heart attack? No. Think about that one. Correlational or experiment? Well, the independent variable would be smoking. So I guess the alternative is not smoking. So smoking or not smoking increase the risk of heart attack. So the outcome would be the cardiovascular disease of some sort, some sort of measure of that. So you'd have to have an experiment. You'd have to randomly assign or assign some people to smoke and some people not to smoke. You'd have to manipulate that. That would be, if you're using people, that would be unethical because you would be assigning people to smoke who normally wouldn't smoke, and could cause some serious health concerns for them. If you wanted to do an experiment, you'd have to use, I guess, you'd have to use animals, when some people would be concerned about the ethics of that as well. So there's a debate there we won't get into, but to run an experiment, you'd have to manipulate that. Otherwise, you'd be looking at correlations, and that's where things get a little bit tricky because there could be other things that differentiate, other tertiary variables confounding your study because there's other variables that would systematically vary with incidences of smoking. Maybe someone who smokes also has a less healthy diet or they're less active, for example, a less active lifestyle. And so maybe it's not so much the smoking, but maybe the other aspects of their lifestyle that are contributing to heart disease or some combination. So it makes it harder to make a causal inference when you're dealing with a correlation. So that's why it took a really long time for people to draw some firm conclusions about the health effects of smoking. You can't really run an experiment with people. They could do it with animals, and so there's different statistical controls to make your correlational study more powerful, more effective, but it is harder. Last one, does membership in a chess club increase high school students' chess playing ability? Membership in a chess club increase high school students' chess playing ability. So your independent variable would be chess membership. So the implied alternative would be not being in the chess club. And then their chess playing ability would be the dependent variable. And when we went over this in class, in face-to-face versions of the class, a lot of people were quick to say, well, this would be a correlation. And you would just look to see which kids were in the chess club and which kids were not in the chess club, and then you just test their chess playing ability, and voila. And again, the problem here is that there's going to be other variables that systematically vary with the independent variable. So the kid that's in the chess club probably already liked chess before they joined it. Maybe their parents or their family members or they have friends that play. And so they joined the chess club after they already knew how to play pretty well. Now they're even better. But they already knew how to play a little bit, and the kids that didn't join the chess club never had any ability to play chess or interest in chess to begin with. And so you're comparing these and saying, well, it must have been the chess club that caused this difference, when the difference would still be there even without the chess club. So correlational studies, you always have to be careful when you're talking about causation. An experiment, this would be better, because you could randomly assign. You could say, who would be interested in being in the chess club, and 100 kids say I would be in it, and then you randomly pick 50 of them to be in the chess club, and 50 of them don't join. Well, now they're all mixed up. There's no reason to think that the two groups of 50 are different, because maybe some of the kids like chess, some of them didn't, some of them knew how to play, some of them didn't, but now they're all mixed up. So we can see if, regardless of their ability to start with, if the outcome is different because of just the chess club. That's the only thing that's different now, because you randomly assign them to groups. That's the power of an experiment. There are some ways to carefully design a correlational study to allow some causal inferences to be made. Some experimental psychologists are very purists, and they say, oh, well, if it's a correlational study, it could never make causal inferences. If it's not a true experiment. A true experiment means that there's random assignment. So you're not just manipulating the independent variable, but you're randomly assigning participants to conditions. If it's not a true experiment, you can't make causal inferences. And a lot of people disagree with that, and they would start to argue that a lot of those experiments are sort of superficial, or in the laboratory setting people behave differently than they would. It's too contrived, and so you can't necessarily say those behaviors would be acted out in the real world. Also, in correlational studies, there's a lot of ways you can use statistical control. So if you know, for example, with the chess club example, you could measure their chess playing abilities beforehand, and then see how the chess club went, and then measure their abilities after, and you could control for their prior performance. And you could make a stronger case that the chess club was improving their performance, pre-test and post-test. A lot of it has to do with theory. With correlation, we'll think of it this way. If you roll a pair of dice and you get a 3 and a 5, and you say, I got a 3 and a 5, and act like that's impressive that you figured out what it said after you rolled the dice, well, that's not impressive at all. You just saw that that's how it was. But if you said, I'm going to roll a 3 and a 5, and then you rolled the dice and got a 3 and a 5, that would be really impressive. Well, how'd you know it was going to come out that way? And so you'd have to have some sort of justification, and then now we're more impressed. So in a correlational study, if you say, I'm going to measure these variables, and you say beforehand, not only here is it how it's going to work out, but here's why it's going to work out that way, that's much more impressive. We can say, wow, these data really support your theory, because you predicted this, and it came out just the way you thought it would, and you can explain why. So that's pretty good. You'll see a lot of that in different fields in psychology, educational psychology, certainly among them. We're working a lot with correlational studies. Okay, so A little bit of review here from this section. Tanya believes that reading in the car will make her nauseous. What are the independent variables? So your independent variable would be reading in the car, the reading in the car, and the dependent variable would be a level of nausea. So reading in the car causes nausea. So to test this hypothesis, number 2 here, Tanya reads in the car on Monday, but she listens to the radio on Tuesday. So is that an example of an experiment, or she looks so nauseous, or of a that's how I look if I read in the car, or a correlational study? So she read in the car on Monday, but she listened to the radio on Tuesday. Well, the difference is determined by whether or not she manipulated that variable. It looks like she did. She's purposely trying to try this out. So she thought, okay, today I'm going to read in the car. I'll see what happens. Tuesday, I'll listen to the radio, and I'll see if I'm nauseous. So that's an experiment, right? Because she manipulated that independent variable.